Welcome to Microprocessor Laboratory. I'm Mr. Rajesh, continuing with the previous assembly language program. Okay, so in the last lecture, we have seen the logical operations assembly language program for using logical instruction set. Today, we are going to see the assembly language program using string manipulation instruction set. So, using this string manipulation instruction set, we are writing two programs. One is an assembly language program to reverse the string and assembly language to find the string palindrome. So, for string of the basic string instruction is move s. That is move string instructions with, to copy from source string to destination string. Okay, so now this copy can be performed on the basis of the size of the operands. Okay, so if the size of the operand is bytes, then move sv is used. If the size of the operand is word, move sw is used, and if the size of the operand is double word, then move sd is used. Okay, so whenever move sd for all these instructions, the default or the implicit segment memory which are used are the extra segment register and the data segment register. Okay, and for data segment register, SI is the implicit register to access the offset address, and for extra segment, DA is the implicit register for accessing the offset address inside the extra segment. Okay, and these string instructions will work depending upon the direction. Okay, so depending upon the direction of operation. So this direction of operation is controlled by a flag called direction flag. If this direction flag is run, our source index register and the destination index register are incremented by 1 byte. Okay, otherwise the source index register and destination index register are decremented by 1 byte. Okay, so that is for move sd. If it is move sw, okay, so word consists of 2 bytes. So if direction flag is 0, our SI will be incremented by 2 bytes and DA will be incremented by 2, and conversely, if DF is 1, our SI will be decremented by 2 and DA will also be decremented by 2 bytes. For move SD, where we are where the string byte is represented in terms of a double word. Okay, so for every one move SD operation and DF is 0, our SI will be incremented by 4 bytes, and DI is also incremented by 4 times. Similarly, SI is decremented by 4 times and DI also decrements by 4 times if direction flag is set to 1. Okay. Now, we will try to write a program for reversing the string. Okay. So the LP for reversing the string. First, we start with assume CS code DS data. So by using the first instruction now, we are going to reserve 64 kilobytes for code for writing the code and 64 kilobytes for accessing the data, and the segment which we are the 64 kb which we are using for data is defined as data segment, and the one which we are defined for writing the code is defined as 4 segments, and we are renaming it as code and data respectively. Now once in data segment, we are defining the string welcome, and we are terminating the string with a $sign. Okay, this is just an indication. Next, lenq is a variable which is equal to the number of locations starting from $to messages. Okay, so $to messages in the sense in the reverse order. Right. So how many memory locations? 1, 2, 3, 4, 5, 6, 7, 8. So this will be the actual strength of our string, including the termination. Okay, so this will be 8, and this will be stored in a variable called len. Right. Next, msgr is a variable which reserves 25 bytes of memory for storing the string reverse. Okay, reverse string. So with this we are defining the data segment. So now let us interpret how the data will be stored in our data segment. Okay, so this is our data segment. Okay, so I can say this as my source memory. Okay, so completely this is your data segment. Data segment. Okay, so in this data segment, so we are defining one memory, say some 2000 we have taken. So here we are referring it as msgs. Okay, so this starting point is msgs, and here we are storing welcome, and w is stored in 2000, e is stored in 2001, l is stored in 2002, like this till 8, till 2007. So now len is a variable, okay, which is pointing, which counts the number of others locations right from $sign to double. So that is 8. Okay, so this is how we have defined our data set. Okay, and coming to the destination, so the memory which is reserved for storing our reverse string. Okay, so that we are say we are starting with, we are putting the 2001 location, so 2009 location, which is pointed, so which we are naming it as msgr. Okay, so for better differentiation I use a different color. Okay. msgr. Okay, so now we enter into the code segment. Okay, and we have started writing the program right by using the assembler directive main. Okay, so from this point onwards, the whatever we write, that will be considered as our assembly language. The first instruction is move ax comma data. So the data segment address is moved to ax, and that is moved to ds as well as es. Okay, so instead of defining the separate extra segment, okay, so we are making some memory location of data segment as extra segment. Okay, so this is how we will define the data segment and extra segment. Means data segment register and the extra segment register are loaded with the starting address of our data. Okay, then SI is moved to msgs, and DA, which is destination, is moved to the offset address of msgr, and move cx comma length minus 1. Why we are taking length minus 1? Because this $sign is known as the termination of the string. It is not actually an character. It is not a part of the string. Okay, so that's why we will be counting only up to this. So that's why len minus 1 we are taking. Okay, so cx is loaded with the actual length, and we are adding di to length minus 2. Okay, and then we are clearing the direction flag. Now let us see what happens to this instruction. So first, here we are making it as SI, offset of msgs. Now offset of msgs is 2000. So SI we are making. Offset of msgr is 2009, which is pointed by TI. Okay. Then length we are making it as length minus 1. So the value of length is 8, minus 1 is 7. Okay. And then what we are doing, we are adding, we are pointing DI to the last location, because string reverse means copying the string in reverse order. That's all. It is not a simple copying. Instead of copying directly, 1 to 1, we are copying from last character to the first character. So first we need to copy the last character. Okay, or the first character has to be copied to the last location of the DA. Okay, so either way we can do. So we are following the second method. So for this, DA is 0.2009 plus length value is 8 minus 2 locations. So now what's the fresh value? 2015. So now this DA will be pointing to DA is pointing to 2005 location. Okay, so now direction flag is 3x, means SI and DI will be implemented for every one copying operation from source to destination. Okay, so first move XB. Okay, so first move XB. So move XB means W will be copied to the destination, location pointed by destination. Okay, then SI gets implemented by one factor. Okay, so DA gets implemented by one factor. Okay, but actually DA has to point to the previous location, isn't it? So what we do, DA is decremented by 2 times. So DA decrement DA 1 time, decrement DA 2 times. So DA now it is pointing to 2014. So one time it is going to be decremented, and the next time it is going to be decremented. Now it is pointing to 2004 location. Okay, so what is the next instruction? Next instruction is loop. Loop means, what it will do? Loop will decrement the value of Cx and check for the value of Cx. If Cx value is 0, it will come out of the loop. If Cx value is non-zero value, it will go to the label which is specified, location which is being specified with the help of a label. Our label is reverse. So now let us see what happens here. So previously the Cx value was 7, now it will become 6. Okay, and this is a non-zero value, so it will go to move FB location. So what, now move FB is executed. So what happens to move FB now? It will copy the character pointed by SI register to the character to the location pointed by DI register. Okay, then what happens? SI is implemented by one factor and DI is also implemented by one factor. Now again SI is fine, but DI we have to move to this location, 2003 location. So what we are doing, as per the code, we are implementing this by 2 factors. Okay, so now Cx becomes 5. Okay, so when Cx becomes 5, what happens? It is a non-zero value, and again the content pointed by Sn is copied to the content pointed by to the location pointed by DA. So now L is copied. Now Si is implemented by one factor and DA is implemented by one factor, and again DA is decremented by 2 factors. So now it is pointing to 2012 and Cx becomes 4 and the contents pointed by SI address location simply copied to the DI address location. Okay, and then SI is implemented by one factor, DI is incremented by 1, decremented by 2. So it is almost decremented by one factor. So now DI is pointing here. Now O will be, and then Cx value is decremented by 1, and then O is copied to, since it is a non-zero value, to DI location. Then SI is incremented by 1 and DA is further incremented by 1 and first incremented by 1 and then decremented by 2. Now it is pointing to 2010 location and Cx value becomes 2. Okay, and now since it is a non-zero value, move SB is executed. So n is copied to this location. Okay, and si is moved to this, si is moved to the next location, and di first it gets increment by 1 and then decrements by 2 factors. So now the ultimate final value will be this, and now dx will become 1. Okay, and then the contents of si is copied, and it is copied to 2009 location, that is pointed by di. Okay, then si is incremented by 1, right, and di is incremented by 1 and decremented by 2 factors. Okay, so first is increment and decrement by, now si and di is pointing to the same location. Okay, so now see, our complete string is copied, but we need to show the termination of the string, that is by the help of $sign. Okay, so one way is making this di to come to this location. So we are not aware of this other location, isn't it? So instead of that, what we do is we will use an assembler directive called byte pointer. So what this byte pointer will do is, okay, so this byte pointer address, so whichever the address we want to go, that address virtually we are going to this location, and we can put some data into that location without actually changing that location, which is accessed by any register. Okay, so this di is pointing to which location? Now, so di is pointing to 2007 location. Okay, plus length. So 2007. So now the new value is di is pointing to 2007 plus what is the length value? Length value is 8. Okay, so now which location it is pointing? It is pointing to 2005 location. Okay, so now the length will become 0 here. Okay, so move SP. So E is copied, and SA is incremented by 1, and DI is incremented by 2. So DI is incremented by 1 and then decremented by 2. Now it is pointing to $sign. Okay, so now what happens? So into this 2015 location, we are going to copy a string byte. Okay, so there is DI plus LEN. Okay, so DI plus LEN, we are going to move $sign. Okay, so this is complete. We are going to store here. Okay, so now this becomes the string. Right. Now what we do, we start displaying message as right from the offset message as with the help of DX register. So whenever a display routine 09 is executed, okay, with the help of AH register, whatever the content that is shown by DX register will be simply moved to the output display. Okay, and once the $sign is found by this display routine, the program it will stop displaying the characters. Okay, so that is why we are using $sign. So we can't use any other sign for this. Okay, so now we are coming out of this display routine, and then we are terminating the program with the help of 4ch subroutine. Okay, with the help of an interrupt 21H. Then code ends in main. Okay, so this is what. So SI and DI are both incremented after data movement. However, what we want to have is SI should be incremented by 1 and DI should be decremented by 1. So to achieve this, we decrement DI by 2 factors after move FB instruction, so that the net effect on DI is decremented by 1. Okay, so now let us see how we are going to execute the same with the help of Amazon software. Okay, so okay, so now we'll go with our next instruction, next program, that is palindrome. So palindrome means, string palindrome means what? So even if we string palindrome means even if we see from left to right or right to left, it gives the same meaning with same characters. Okay. So that is what is known as string palindrome. So the best example for string palindromes are little. Okay, I'll take little instead of akka. So during the execution, I will change it there. Little or Malayalam. These are string palindromes. Okay, palindrome strings we can say. Okay, so what we can do here is there is an extension to our previous program. So till string reverse operation, everything is the same. Okay, so once we copy the string from one location to other location in reverse order, our parent string will be there and reverse string will be there. Now we start comparing each and every string. Okay, each and every character of that string right from starting location. Okay, so if any character is not matched, we are going to come out of the loop. Okay, and if they are matched, we are going to go for the next location and we are trying to compare it. And this will go until the last character is formed. Okay, so for that, so if you see carefully, here I have added two more extra. We have added two more extra messages. One is message palindrome, message not palindrome, and we have written some message titled palindrome and not palindrome. And for each and every character, we have written it is being defined as a byte. Okay, and till move byte ptr da plus len, the program is same, the string reverse only, and it operates in the same fashion. Okay, next move xi offset msgs. So we are going to the starting location. Move da comma offset msgr. Move cx comma len. Okay, and we are, so first we operate this V condition. So now we have resumed here, right? Now what we are doing, SI is pointing to MSGS, DI is pointing to MSGR, right? And now CX is moved with not length minus 1, we are just moving the length, complete character. Here dollar sign is there. Okay, so length, we have simply moved it as 8. Okay, so now what we do here is REPE, repeat the string operation until equality is occurred. Okay, so until equality is occurred, we are going to repeat the comparison operation. CMPS refers to compare string byte. Okay, so here each and so the contents of source index register and the contents of DX register, the contents pointed by the source index register and the contents pointed by the DI register, both are compared. If it is equal, okay, if it is equal, CX is going to be decremented by 1 factor and SI is incremented by 1 and DI is decremented by, so DI is also incremented by 1 and again we are going to repeat the comparison operation. Okay, and at any case, if this comparison operation fails, if they are not equal, immediately we are coming out of this repetition. This not equality exists, and we are coming out of this comparison process. Okay, so if it is, since it is a non-zero value, okay, so we are checking the condition of JZ. Okay, jump for 0 to all locations. If all the characters are compared, means if CX is becoming 0, 0 flag will be set. Okay, and PL, we are moving to PAL location, PAL, where we are displaying the message for not palindrome. Okay, if 0 flag is existing, means all the characters are being compared. Okay, and all the characters are equal in source as well as destination location. So what it will do? It will it will display the not palindrome message, and we are directly jumping to the display routine move AH, 09, and we are terminating the program as usual with the help of 4CH subroutine with the help of an interrupt INT 21H. So now let us interrupt this part of the program. Okay, so now we have copied the string here, and SI and DI is pointing to the starting address of the original string and the reverse string. Okay, so first CX is 8. Okay, so it is non-zero value. Now what we need to do? Compare W and E. Okay, so now see here, for this string, for this welcome string, the first two characters are not equal. So immediately it shows that the string whatever we are using is an not palindrome string. Okay, so first we will take a palindrome string. So how many characters? It is 7 characters. Okay, so we will take a string which is of 7 characters. Okay, so let us take a string with 7 characters. So randomly I am taking A, B, C, D, C, B, A. So there is one character, so one string which looks like a palindrome. So when we copy this, we are going to get the same string here. Okay, so now let us interrupt how it will go. Right. So as per the program, it is 8 minus 1 actually. So length minus 1, a small mistake is there. The program. So here it's not just Cx, it is Cx minus 1. Okay. So the same we will try to implement here also. So now Cx will become 7, right? And now we assume that the strings has been reversed. The string is reversely copied. Now, okay, so first A and A means the source is pointed by to A and DA is also pointing to A. So now what happens? A and A gets compared. A and A are compared. So since A and A are equal, okay, so it becomes equal condition. I'll write equal condition here. Okay, so once it is equal, then what happens? The Cx value, one comparison is over. Now Cx value is decremented by 1, and we are going to repeat. Cx value becomes 1, and SI will pointing to the next location and DI will point to the next location. Okay, and then repeat the comparison operation. So repeat for equality condition. Since it is equal, okay, so SI is incremented by 1, DI is incremented by 1. Now we are going to compare these two, B and B. Both are equal. Okay, so once they are equal, right, SI will be incremented by 1 factor, DI will be incremented by 1 more factor, means it is pointing to the next location. Cx value will become 5. Okay, so Cx value is 5. Then we repeat the comparison operation. C is compared with D. Okay, and both found to be equal again. Then SI is incremented by 1 and DI is incremented by 1 and Cx is decremented by 1. Okay, and since Cx is a non-zero value and the previous condition is also equal, D, the contents of SI, which is D, and the contents of DI, which is also D, both will get compared and we get equal condition. Okay, so after both are said to be equal, after comparison operation, SI is incremented by 1 and DI is also incremented by 1 and the length is decremented by 1 factor, which is 3. Okay, so now what happens, we are repeating the same comparison operation between C and this thing. So again both are equal. Okay, and SI is incremented by 1 factor and DI is incremented by another factor. Okay, and Cx becomes 2, right, and since it is Cx is a non-zero value, both D gets compared since they are equal. Since they are equal, your SI will get incremented, DI will also get incremented. Okay, and Cx becomes 1, right, and then both are equal condition, right, and then SI is pointing to the next location and DI will be pointing to the next location and Cx becomes 0. Okay, so once Cx becomes 0, right, there is no need of comparison there, right, so our control will come out of this loop, out of this REP comparison operation, and then we are checking the condition of 0 flag. Okay, so if when 0 will be existing, when Cx value is 0, 0 flag will be set to 1. Okay, so now what is the value of Cx? Cx is 0, means 0 flag is existing. So when 0 flag is existing, where we are moving? We are moving to a location called PAL. So PAL means palindrome. So what the palindrome location, what instruction is having palindrome? PAL label. We are having move dx, offset MSP P. So what is MSP P? MSP P is known to be the palindrome. Okay, so now our dx is pointing to MSP P and we are running the display routine 09H with the help of interrupt 21. Okay, and this message will be displayed until $sign is found, and once $sign is found, immediately we are coming out of the display routine and we are terminating the program with the help of 4CH and interrupt 21H. Okay, so hope you understood this. For suppose any character, I am just making this as a small c instead of capital C, small c. So now these two are unequal. So now here it becomes unequal. equal and equal. Okay, so now immediately when it is unequal, okay, so this comparison will no more exist. Okay, so we are repeating for equality condition only, right? Okay, so once it becomes unequal, we are coming out of the loop. Once we come out of the loop, okay, the Cx value will be obviously a non-zero value. Okay, and this condition will fail, and next instruction will be executed, that is not palindrome instruction will get executed, and we are jumping to the display routine. Okay, so hope you got this. So now we'll execute this with the help of a manual. So this will end our ALP for string palindromes. So during runtime also we can do the operation, we can give the inputs. Okay, so that if anyone asks me personally, we can do it in the laboratory. Okay, so first we work on this, and for runtime program, for giving the input during the runtime, we will execute at that time, and just think how to do that also. Okay, thank you.